gasoline compression ignition engine concept is basically taking the best of both worlds of a diesel and a gasoline engine. And diesel fuel, when it's injected into the hot air that's compressed,
it ignites.
It ignites immediately. Gasoline, there's an ignition.
Spark.
There's typically a spark, and then there's an ignition delay. But what we're actually taking advantage of here is you inject it in, and then it gives it time to mix with the air properly, and then it ignites after the ignition delay. And since it's more well mixed in that area, it will actually then burn a little bit cooler, and the emissions will be better, and then the efficiency will be better, because as the combustion temperature drops, you lose less of that heat energy to the metal surfaces. So you gain efficiency and you get better emissions. So that's kind of the main item here. And actually, Mazda's Skyactiv X they are taking advantage of a small portion of this type of operation.
So it's a little bit in cooperation with Mazda technology?
We actually are working with Mazda on some technologies. Their concept specifically still uses the spark, but it's getting closer to the full gasoline compression ignition concept.
Can you do this concept with all engines, or are you just delivering some products of yourself?
So we are trying to work in collaboration with the OEMs, and we have PSA and Mazda are a couple of our collaborations, and we have some other collaborations that are not quite public yet, but we'll hopefully be able to announce soon. And so this is one concept. We want to check out the turbulent jet ignition over here.
Yeah, sure.
So unfortunately, our video is not working there, but it shows a pretty good. I'll try to describe it myself here. But so turbulent jet ignition, one of the major challenges with a spark ignited engine is igniting a lean combustion mixture, right? So when you fire the spark plug, sometimes that little flame kernel will start and then die out, right? And it won't completely burn, so you get a high variation in your combustion.
That's true.
So the way you can get around that is this is called a pre-chamber.
Yes.
And in the pre-chamber, that volume in there, we ignite the spark in there. It's a nice calm environment, and we try to target a lambda 1 in here, or near stoich. And then in the main chamber, we try to maintain it globally lean, or very lean. And then what happens is it ignites very easily in here, and then it shoots out through those small little holes, and it makes little jets. And then those jets have two things that help ignite the rest of the chamber. It's very high temperature already, and then they have also some radicals in there that then help promote the combustion. So then you have the one spark, which then shoots into these jets, and then all those jets become a bunch of different ignition sites within the chamber.
So it's nice to spread over the whole cylinder.
So it speeds up the combustion, and then it burns more completely. So that helps in two spots. It'll help at very, very light load. You can run very lean, and then you can avoid throttling losses. And then it actually helps at high load, because then you can actually burn the whole chamber before it knocks or auto ignites, right? So those are the main benefits, that the low load and the high load. And we had to achieve this the way we have a direct injector that's targeted right in this area. And then we have a PFI injector here. So
you can pre-combine the air and the fuel together.
Yeah, we pre-combine some with the port fuel, and then at the last, near TDC, we're putting just one little stratification pulse that will target this area, which will then get pushed into the chamber, right? We want to be around stoich in here, and we want to be lean, globally lean everywhere else. So that's how we're accomplishing that. So this is a production engine that we've modified this is a custom intake manifold, and it was side already, but this pre-chamber device fits in the existing, spark plug tap there, and then we just have a smaller spark plug in there. So minor modifications, then there's a lot of calibration modifications required.
And I actually never heard of this because I'm from Belgium, but when can you order this actually? When can I see this on the streets?
So it's actually in an F1 race cars already.
All right.
Yeah, the technology is.
So it has some performance availabilities.
Yes, yeah, it makes the
nice.
combustion very fast. So we have this in our tomorrow section. We kind of sort of segmented the booth a little bit here. So it's not in a production vehicle yet, but like I mentioned, we're working with OEMs to develop this technology. This is one iteration or one way you can actually accomplish this. There's other methods this is a passive system.
Yeah.
So there's other methods that are active systems that actually will inject either fuel and air then into the pre-chamber.
Oh, that's nice.
So because the big challenge is scavenging that and then also keeping that at a different air-fuel ratio than the main chamber.
Yeah.
So that's what we're trying to accomplish.
It's a very nice concept.
Yeah.
Actually, I love it. Yeah, I thank you very much for the interview.
Yeah,
It's
no problem.
very nice for my school project.
Yeah, good luck.
Thank you. Hier is eigenlijk een soort van motor. Formule 1 technologie eigenlijk, dat bestaande motoren kan ombouwen tot een betere verbranding eigenlijk. En als je een betere verbranding hebt, zo arm mogelijk, dan kun je eigenlijk meer pk's winnen, meer efficiëntie. Eigenlijk alles is veel beter van een gewone motor. En ze werken momenteel samen met Mazda en PSA, dus de Peugeot Citroën groep, voor dit de dag van morgen op straat te brengen. Momenteel, kom even zien. Momenteel bieden ze ombouwkits eigenlijk, zoals je hier ziet. Dit is eigenlijk een inbouwkit. En ze hebben ook heel de inlaat veranderd door 2 aparte injecteuren te gebruiken, waar een veel directere en preciezere verbranding kunnen krijgen. Dus door dit wordt het proces van de verbranding van een motor eigenlijk veel beter en krijgen we veel betere prestaties eigenlijk. Ja, dat was een van de technologieën hier op Genève Motor Show. Ik kijk heel hard naar deze, want ik zie niet graag de verbrandingsmotoren sterven eigenlijk. Dus eigenlijk wel een heel mooi alternatief voor de gewone verbrandingsmotor om toch tegen de elektrische en hybride wagens op te kunnen. Ja, voilà.